12 minutes or so for...
Okay.
Yeah.
Okay, thank you.
2 minutes for
Good evening, ladies and gentlemen. Thank you, Chairman. Hydrogen is considered to be one of the future fuels. And the word hydrogen is also one of the magic words in our fight for the climate change. We are all looking forward for implementing hydrogen as a pathway to decarbonization. So what Chairman has just pointed out, to plan and execute a kind of infrastructure, I have a few points to discuss with you. Hydrogen has different color codes. We are talking about green hydrogen. When hydrogen is produced through renewable energy inputs, it is called green hydrogen because it does not emit any carbon dioxide during its production. Also, we know that when hydrogen is burnt in the air, it doesn't emit any carbon dioxide. When hydrogen is used in fuel cells for production of electricity, the byproduct is only pure water. So countries are planning for huge investment in hydrogen. Some countries have already started that investment. But when we are doing hydrogen, we need to remind ourselves of one very particular question, that is safety of the hydrogen. But fortunately, significant work has been done on safety of hydrogen infrastructure, its production, its distribution, its use. Industry has contributed extensively in this exercise. Standards have been set up. Guidelines and regulations are continuously being updated. But there is another question regarding hydrogen. That is what they call the leakage of hydrogen into the atmosphere. Hydrogen is a very small molecule, if you see H2, and it's very difficult to contain. It does leak. But if hydrogen leaks, then what is going to happen? If it leaks, and that leaking is possible in the throughout value chain, if where you are using hydrogen is far away from the point of production, then you have to take it to that distance through pipelines or through other means. Now, if hydrogen leaks, then what happens? The very good thing is that majority of it would be absorbed by the microbes on the soil. But then still more hydrogen will go up. And it has been found that these hydrogen can cause global warming. It's very interesting. Hydrogen does not trap heat itself. And we are using hydrogen to contain global warming. But like Lenge's law in physics, what we have learned in class 9 or 10, it probably can cause global warming if not properly planned. Because this hydrogen which is coming out, whatever is there, will react sharply with the hydroxyl ions, OH, with unpaired electrons. And this OH, which is in the troposphere, the lowest atmosphere, is considered to be a very important element in the atmosphere. as rightly pointed out by Nobel laureate Cruzen, that it is the detergent of the atmosphere. Detergent in the sense, suppose carbon monoxide is being dumped in the atmosphere, it goes there, it reacts with the hydroxyl ion, becomes carbonic acid, comes down with the rain. Yes, it is the acid rain, but the atmosphere gets clean. This hydrogen, when goes up, it will react with that hydroxyl ion and will produce water. Good. But you have to remember, this hydroxyl ion is also used by methane, one of the most powerful greenhouse gas, to be degenerated. Because that hydroxyl ion reacts with methane, CH4, takes out one hydrogen, produces water and methyl radical. That methyl radical, through a series of chemical reactions, become formaldehyde, and ultimately through the ultraviolet radiation that formaldehyde gets destroyed and comes down. So methane gets degenerated by this hydroxyl ion, and methane is the most potential greenhouse gas, 80 times more potential than carbon, with global warming potential than carbon dioxide in a 20 years period. So when hydrogen comes, it becomes a competitive thing with the methane, but hydrogen being more potent, it takes up the hydroxyl ion. The methane loses its detergent to be cleaned to some extent. That means it is increasing the amount of methane. Hydrogen, it cycles out from the atmosphere within 4 to 5 years. Carbon dioxide remains there for centuries. Methane also remains there for quite a long time. So probably it would be, if it really contributes to the global warming in this way by increasing the amount of methane in the atmosphere, or leaving out water in the stratosphere, which also acts as a global warming element. Its effect may be for a few years, unlike carbon dioxide or methane. But we have to remember, when we are increasing the hydrogen utilization in such a faster way, International Energy Agency has told that by 2050, the use of hydrogen would be many, many folds than what it is today. Today we are not getting that global warming theme from hydrogen, because use of hydrogen is very less, minuscule in the refineries or in the fertilizers and all those places. But what we are planning, as this session talks about, as Chairman has pointed out, plan and execute, we have to remember these negative aspects. When researchers have flagged it, they're telling they're not demeaning hydrogen, but only to flag the problems before we plan that infrastructure. I'm giving you an example. Already in many countries, hydrogen is being put in the gas pipeline. Certainly, it is replacing methane. Methane, if you burn, it gives out carbon dioxide. Methane also, if it leaks, is a very potent greenhouse gas responsible for global warming. So if we replace methane by hydrogen, it's a very, very positive aspect. But what we are doing, we are putting hydrogen in a gas pipeline which has originally been designed for methane. And methane molecule CH4 is much, much larger than the hydrogen molecule. And there are technical evidence, there are a lot of studies, methane does leak. So if methane leaks from that pipeline, hydrogen being very, very small molecule would leak in many other, in many times. The evidence says it is 2 to 2.8 times than methane. It has the potential of leaking from the same gas pipeline. Now, when we talk about safety standard, leakage of hydrogen, there is a threshold. Above that threshold, certainly it is not allowed for the safety reason, and therefore it is strictly being monitored, and all engineering details have been worked out to see that it doesn't leak crossing the threshold limit. But below that threshold limit, not much work has been done. It is to be very seriously monitored and to see that these small hydrogen molecules, how much it leaks, and with the planning, with the extrapolation of the utilization of hydrogen in the future, 2040, 2050, and beyond, how much hydrogen is coming, and hydrogen, how much it would be leaked to the atmosphere. We therefore need to put this question to the researchers, to the industry, to the technologies, so that real serious work is being done. Policymakers must consider that this is another potential problem. We welcome hydrogen. We welcome it for reducing the global warming, but then we will have to take all necessary precautions if we want to plan in a big way. Thank you. This is another thought, and you can consider.